welcome you all for the next session, where in the previous lecture we have seen an introduction about packaging. Now we'll explore into the functionality and we'll go for the different types of packaging. So let me start. The functions of an electronic packaging. So you can see the functionality in such a way of an electronic device. So this is a IC. So IC packaging, we have different types. So different vendors are going to provide you the IC and the packaged IC. It can be dual in pack or it can be a single in line. So packaging, how the leads are going to project outside. So that is also our most concern. So if these leads are going to be inserted by means of a through-hole technology or by means of a surface mounting part. That is another part of your IC. Now coming to the design. Single chip. First let me take a single chip because the concept is very much understood only from this single chip packaging, where from a wafer we just make an IC. And this is a single chip factory unit where it comes under the level 1. So I think now the concept of level 1, level 2, level 3 and 4 is understood by means of the previous lecture. So now coming to the chip on board, multi-chip, and then how this level 1 can be taken for a module. It is for the level 2 type of packaging, and onto the motherboard where the level 3 is also possible. So now each and every part is of essential if you take. So the functionality is going to provide you with electrical and mechanical support. That is a protection. Heat dissipation is also going to happen because continuously an IC is going to work for 24/7 for n number of days. So if it's going to be any simulation as I got an experimental part which carried out by means of the practical prototype which we have built, then the dissipation is of utmost concern. Sometimes it may cause a failure also. So if your IC is going to burst out, then what is going to be the outcome of it? So nothing. So like that, we need to plan for a heat dissipation concept by means of a heat sink. That is another concern where it comes under the thermal aspects of your design. So electrical connectivity, mechanical, and coming to the heat, and at last a protection unit. So these are the four main counterparts which you need to accomplish whenever functions are going to be explored. So now look into this particular diagram which will give you the printed wiring board. A ball is going to be there which is a bonding pad attachment onto the substrate of your material, and then you can have some underfills, and these underfills are going to be with respect to the connectivity part. And at last you have the chips. So the chips, how it is getting bonded, it can be by means of a wire. If it is definitely by means of a wire, so I have a chip placed on top and then I have the substrate material. From the substrate to the chip, we have a wire bond. So this wire is going to be a very thin wire. Either it is established by means of aluminium, or you can go for a high density, or it can be with a high cost, like gold wires are also used very high precision in the case of a sensor unit. So this particular wire has been taken for signal connectivity, and from this bonding pad substrate material, it is connected to the chip. It is a chip which is placed on top. This particular chip will have a top face as well as a bottom. The bottom is placed and top is going to face upward, and then you can have some encapsulation. The black color outer covering which you can see here, the encapsulation, and this encapsulation, it can be a plastic encapsulate or it can be a metal. Metal is going to be conductor, so we just go for some other type, a polymer encapsulant, or it can be a ceramic, different types. You can. So this is going to be the wire bonding feature. It's a very essential part in packaging how connectivity is established. Because out of the four functions which you can see, electrical connection is going to be the first, and then the mechanical support. How? The support. If it is loosely held, support cannot be made. But heat dissipation also we need to consider. When some kind of heat sink, we need to fix it. And protection is obviously done by means of the encapsulation, which we so these four functionalities have been accomplished by means of the wire bonding principle, and wire bonding is a very cheapest type of bonding which we now coming to wafer, a diamond blade, die attach, and then we are making a chip. From the chip, we just go for the packaging unit, just prefer a wire bonding principle, wire and a chip. So this particular part only I have explained here. So I think the concept is very, very clear. So the functionality of packaging is understood by this wire bonding principle. So encapsulation has been done. Almost we have this plastic package. Also you can see a black color out of fitting for your IC. So this black color, it is for the heat dissipation. So automatically a heat sink has been inbuilt, and then we have a plating, trimming, forming at last. We have a finished unit, which is your IC, which is packed. So this is the packaging of your IC. Now coming to the functionality, as already mentioned, protection from the environment, from moisture, shocks, and extreme temperatures, and also hermetic sealing is a very important type of sealing which is accomplished for all the sensor and sensitive applications, electrical connectivity by means of tiny chip terminals, power supply, signal transmission with a grounding feature it is, and coming to thermal management and thermal conductors and overheating, and also coming to the long-term reliability functions. And coming to the mechanical support, so how it is fragile and how it is suitable for a silicon die. And coming to the manufacturing, testing and integration, how standardization can be done for automation. And signal integrity, it is by means of the electromagnetic interference and control, and controlling impedance with minimizing the cost of noise. EMC, it's a very good part in interference shielding. So functionality, what would be the description behind it? Electrical connectivity, heat dissipation, mechanical support, and signal integrity. So these are the functions of electronic packaging. Now look into this concept of single chip and multi-chip. So the main concept of packaging proves that signal distribution is going to happen. Signal and power distribution can happen through leads and wire bonds which have been attached. And heat dissipation is a prominent part where leads and chip support are going to have this heat dissipation and support and protection. Now coming to wire bonding with a single chip packaging unit, the outer leads are going to have a connection, the external boards, maybe a breadboard if you make. Only the leads are going to be connected, right? And then you have a plastic encapsulant, which is outer covering. A chip has been placed, and die attached pad is going to be there. The lead frames are going to be there. Wire bonding is established between the outer leads and to the chip. Only by means of this, the chip is going to have a communication to the external environment. It's going to be with a single chip. Maybe the multi-chip is going to be hard. It's going to be with more than two ICs. We can call this a multi-chip. Here, say for example, here the three chips have been placed. The three ICs have been placed onto a MCM substrate. It's a multi-chip module substrate. A single substrate is going to bear all those three ICs. It's going to be attached by means of a resin or by means of an adhesive. It can be attached. So now wire bonding is established. So these are the wires which have the connectivity part to the substrate and to the chip. And also the substrate is going to have a connectivity from the outer leads. This is the external connectivity. Now coming to the functions, physical support, physical housing, that is encapsulation, and removing the heat by heat dissipation, electrical connectivity, and wiring is prominently established by a wire bonding technique. Now coming to the summary table. So these are the functionalities which we have seen right now, and with respect to that, now we have levels. How these levels, so this has been taught in the previous lecture where we had the introduction and the hierarchy of packaging. Now level 0, it's a chip level. And coming to level 1, which is a component level, here only the dual inline package, or it can be a single IC and BGA with respect to the ball grid array type of packaging or involved. It's a single IC package, single outlet with respect to an IC package, and PCB level is going to be totally different by means of a board. Either breadboard is now it has been taken in the form of a PCB board by FR4 board or any different types of boards you can have. In that you have the copper traces, wires as well as a solder masking. So level 1 is going to be the chip package. Wire bonding, flip chip, and other types of techniques are involved only in level 1 type of packaging. Level 0 already it's a semiconductor IC, the wafer preparation, that is level 0. Level 1 is chip, and level 2 is going to be the PCB level. And coming to the module assembly, so we can see this MCM and system level is going to be the final with enclosures, cooling system, power supply, interfaces, everything. That is your laptop and smartphones. So these are going to be the level 4 system level integration happened, and only it has started from level 0. So that we should remember, because level 2 cannot be there without level 3. So that is the sequential order which has to be followed. So just now what we have discussed, so everything we have seen. And level 5, it is between the systems we can establish between a host computer terminal to a printer. So like between the systems, between the two types of systems you can have. Now I want to explore in detail only with respect to this. That is level 1 type of packaging. So where this level 1 comes, it is the IC and its packaging unit, how it is getting packed. Either we can go with wire bonding, or we can go with the flip chip, or we can go with the tape automated bonding. These are the three types of bonding which is there in the level 1 type of packaging, and that is of utmost concern into our syllabus. So everyone has to concentrate only on this level 1 type. So these are the descriptions which are being made, and level 1 component chip packaging with a dual inline BGA quad flat pack which is available in all the transistor packages. So totem hole package, plastic package, lot of vendors are doing this packaging part. Once it is perfectly packed, then we can use it for our design. So MEMS packaging if you take. So here traditional packages are available and chip on board where MEMS mounted components directly on the substrate. Either it is wire bonded and simply it can lead to large packaging size and limited precision is there. So chip on board is going to be the cheapest. Flip chip if you take, so flip chip, it's a MEMS chip which are flipped and connected to the substrate. Flip is like upside down. You convert it, just change it. The solder bumps are going to be there for shorter connectivity. Bumps are nothing, it's a small ball. It's a very small radius, how you can have a circular ball. So that is a solder ball arrangement. Wafer level also you can have a packaging at different wafer scales where it is diced into individual chips. Compact, lower cost, better thermal management, and often it includes a wafer with silicon or glass, which is for the protective cavity and suited for devices like RF and optical. Sensor design with miniaturization is going to be a critical aspect. Now coming to package free integrated one, low temperature core fired ceramic or grid array type or it can be a chip scale packages. There can be a direct integration, which reduces the size and improves the performance. When you take a system in pack, SIP, this is also a very good terminology and a topic need to be discussed in multiple ICs whenever integration is possible. The ICs are going to have some passives and allowing the combination of these chips from different technologies and vendors. Here it is ideally suitable for complex applications and which have been inbuilt into your smartphones, medical devices or as well as automotive electronic applications. Flip chip is going to be a latest technology which reduces the interconnect length, improves the signal integrity, and also thermal conduction is possible. Solder gums, they provide a high density interconnect and it is suitable for high speed computing, telecommunication, advanced sensor applications. So now integration, caps or lids, or it can be with a sealing. So sealing here it is achieved by bonding techniques. We'll be learning about the bonding techniques in the other sessions. And ceramic is going to be a very good and excellent electrical insulator where it provides a hermetic sealing and mechanical strength. Integration of MEMS with ICs, hybrid chip modules are possible and they can be fabricated and separated and assembled together. So with this, the chip is going to be with an SOC form and reduces the size. And when you go with challenges, protecting the fragile moving parts and managing the stress, ensuring the hermetic sealing, balancing the cost, size and reliability. So all these will be included in the packaging steps. Then these are the summary of the packaging techniques which we have explored right now. So with this, we just conclude our session and we'll go for the next session where it's a continuation of these topics. Thank you. Have a nice day.